Welcome to our review on longitudinal waves and ultrasound. So when we're thinking about our longitudinal waves, what we need to think about is the direction that it's moving and the direction the particle's vibrating. So if we've got these vibrations which are travelling through the air in the same direction that the wave is moving in, then we've got a longitudinal wave. And what we've got in that diagram is a little picture of what we could expect it to look like on our exam paper. So we've got two key sections that we need to remember the names of, which are the compressions and the rarefactions. So our compressions, as the name suggests, are the areas that the lines are very close together, and the rarefactions are the spaced out areas. So do remember those two labels, because they do like to ask you to label them on a diagram every so often. In addition to that, they'd like to ask you what the wavelength is in a longitudinal wave, and that's just the actual distance between the centre of one compression to the centre of the next compression. So we should remember that these longitudinal waves, examples of them would be sound and P waves, which hopefully we remember from our topic in our core science on earthquakes. The other type of wave that we've already encountered are transverse waves, and our examples there are water and the electromagnetic waves. There are four definitions we need to remember then for this bit. First one is the compression, which is the region of higher pressure where the lines are obviously going to be much closer together on our diagram. Second one, the rarefaction, is the region of lower pressure, the lines are more spaced out. Third one is frequency, which is the number of compressions passing a given point each second, and as with previous frequencies, it's measured in hertz, which is the symbol Hz. And finally, the wavelength, as we've already said, is the distance between two compressions. If we're thinking about sound, there is a certain type of sound that can't be heard by humans, and that's ultrasound. As humans, we can hear sounds with frequencies up to 20,000 hertz. If we have a sound wave that's above that frequency, then we have an ultrasound. Now, we can't hear ultrasound, but other animals can.